is when the function is monotonically increasing of x or decreasing of x. And we came up with the result that the combined result basically that the PDF of y equals the PDF of x multiplied by the derivative dx dy or divided by the derivative dy dx. And of course, this is evaluated at x equals the inverse of the function with respect to y. And we took several examples on that. And we stopped basically in the second example. In the second example in this slide, we already gave several examples before. So the second example is, now today, inshallah, in this class, the objective is to continue with this example and then talk about the general transformation when you have non-monotonic function, as well as the transformation of a discrete random variable. This is what we'll do, inshallah, today, with some examples on both. So the second example here, we have a random variable x that undergoes a transformation, which is defined as y equal minus 3 divided by x. Find the density of y in terms of the density of x. So assuming that we know the density of x, we are interested in fy. So assuming that we know fx of x, we want fy of y. Okay? So what is the rule here? Fy of y equals what, Shabab? It's fx of x. Yes?
Times 1 over the derivative of dy with respect to x.
Yes, dy, exactly. dy dx, absolute value. And all of this is evaluated at x equals t inverse of y. So what is dy dx? Shabab? We have minus 3 over x. What is dy dx? Shabab, please try to wake up with me. Try to participate. Different students. What is dy dx?
3 over x squared.
It's 3 over x squared, right? Okay. So basically we have here, then basically if we continue, this is fx of x divided by 3 over x squared, right? And all evaluated at x equals, what is x equal with respect to y? What is the inverse of t here? Shabab, y equal minus 3 over x. So what is x equal to?
Minus 3 over y.
Okay, so basically this is equal to fx of x, sorry, minus 3 over y. Let's put it together. Divided by 3 over x squared. So x equal minus 3. So it will be 3 over minus 3 over y all square, which will be x of minus 3 over y. Now we have y squared in the denominator. That will be y squared here. And we'll have 3 over 9, which is 3, right? And this will be the answer. So if you know fx of x, simply substitute x by minus 3 over y, and you will have multiplied by y squared, and you will have basically your new PDF of y. So this is basically the PDF of y. واضح يا شباب? Any question? Any question? So it's very systematic, as you can see. Yani if you are good at calculus, it's basically very systematic. طيب, now if you have non-monotonic transformation, non-monotonic means the function goes up and down, like in here. So you can see here it goes up and then it goes down again. And examples are basically x squared, y equal x squared, right? Or y equal, what is this? cosine x, and so on. All these are basically non-monotonic functions. Now, I would like to find what is the PDF of y if I know the PDF of x, in terms of the PDF of x, in this case. Well, you can notice here that if you have here several zeros, so this is, for example, these are the zeros, x1, x2, x3, are the zeros of y equal t of x. So if we solve for this, we can see that we have several zeros here, 3 zeros. And all of them correspond to the same value, y0. Okay? So in this case now, if we would like to ask ourselves, what is the probability that y, or fy of y, which is the probability that y is less than a number y0, if y is 0. This is, when does y is less than y0? This is basically y0. So y is less than y0 when y takes values in this range. But when does y take value in this range? When x is less than x1 and when x is between x2 and x3. Okay? Now, if we go through the same process that we have done before and we differentiate, and we will find that, we will not go through this here, we'll find that fy of y equals the summation of n, the n zeros of y equal t of x. We sum over the n zeros. Here, how many zeros do we have in this particular example?
3.
3 zeros. So here, in this particular case, we sum over 3 values of x0. So x, fx of xn. So here, xn here is the nth zero. And divided by dtx dx evaluated at x equal xn. Okay. واضحة يا شباب؟ Okay, so basically in monotonic we had only 1 0. In monotonic, either increasing or decreasing, we have like this. So for y0, I have only x0. And because of that, I only have one term here in the summation. So we have here 0, which leads to one term in the summation below. Okay. Now, if I have in general, for example, in this case, I have 2 zeros. Right? For the cosine, I have infinite zeros. So it will look like only an equation. Okay. The point is, I sum over all the zeros of this equation, y equal t of x, and then I have fx evaluated at xn divided by the derivative of tx dx evaluated also at x equal xn, where xn here is the nth zero of t of of x. Y equal t of x. واضحة يا شباب؟ Any question? We'll have examples. However, do you have a question about the concept here?
The value for x is the value that corresponding to y0 or the zeros of the function?
The zeros of the function. Here, we started here with y0, and we said that it has 3 corresponding values. And we defined this, if you remember. And now if we continue the derivation as we did before, we will end up with the same, with this result. Fy of y will be the summation of the nth zeros of the same equation that we had before. However, every time we evaluated at different zeros.
Okay.
Let's have an example. So we have here then non-monotonic transformation y equal t of x, which is cx squared. Okay, so it looks like this. T of x looks like this. Okay, so for the specific y0, we have two zeros here, or two values of x. So in general, if we have y equal cx squared. Now, if we solve it, I have two zeros here. x1, which is minus y, first zero, minus square root of y divided by c, and the second zero is plus square root of y divided by c. Simply نحل هذه الإيكويشن. Okay, solve for x. We get basically these two zeros. Now, in order to find the PDF of y will have how many terms in the summation, Shiba? In this summation, how many terms we have for this particular example?
Two.
We have two.
Two terms, because we have two zeros. The first term is, so basically fy of y, let me write it in details, will be the summation of I equal 1 to 2, okay, of fx of xi divided by dy dx evaluated at xn, x equal xi, so. Okay, so basically so we have here two terms. It's fx of xi. What is the first xi here? The square root of y over c multiplied by the derivative. Divided by the derivative. What is the derivative dy dx here? So, what is dy dx?
2cx.
2cx. Evaluated at x equal x1 plus the same. However, now we have the second zero minus y over c divided by 2cx evaluated at x equal x2. Okay, but what is x1 here? x1 is whatever. We started with x2. We started with x2 here because this is x2 and this is x1. So basically, if we do this and we replace x1, we will have basically the first term. Basically, we'll have this. The first term is fx of square root of y divided by c divided by 2c. But what is x1? X2 here. It's square root of y divided by c. Right? So 2c square root of y divided by c. And we have the second term, which is fx of minus, which is the second one, y over c divided by, now x2 is minus y square root of y divided by c. Now adding them up, we will get basically this result. So, clear?
Yes, clear.
Yes.
Any question? Now, if we have a discrete random variable, it's more, I would say it's easier to deal with discrete random variables because we have the PDF is a probability, is a set of probabilities. So the PDF of fx in general is a summation of delta functions, each at different values of x in the random variable x, multiplied by the probability of that value, x in. Okay, so we have here in general a discrete random variable will have basically its PDF in general, as you have learned before. It's basically certain delta functions. And so on. So this is x1, x2, x3, x4, and so on. And this is the probability of x4, this is the probability of x3, and so on. Okay? So now if I have, and the same thing, the CDF, except that we have u functions, which is the step function. So if I have x of t goes through the transformation t of x to get me y of t. X is a random variable, I'm sorry. The transformation is t of x, and I get the output y. I'm interested to find what is the PDF of y. In order to, I know that because x is discrete, then what is y? What would be y? If you input a discrete random variable to any function, you will get also a discrete random variable. Okay? So because I know it's discrete, then I'm expecting that the PDF will look like this. Series of random of deltas at different y ends, and everyone is multiplied by the probability of yn. So in order to find the random value, the PDF of y, I simply need to find the values that yn takes and the probability of every value. Okay. Now, if I have a monotonic function, بمعنى a monotonic function, the function t of x goes like this زي ما قلنا يطلع اتجاه واحد أو نازل يكون. Then for every value xn, I will have how many values for y? One value, right? Because it goes up or down monotonically. So for every xn, I have one yn, which is the value of yn will be t of xn, the function evaluated at xn. And the probability of this yn, its probability equals the probability of happening of xn. واضحة؟ Okay, for monotonic functions, for every value x, I have one value y. And this value y will be the function evaluated at this value x. And the probability of yn equals the probability of this xn. Okay? Yeah, for example, if we have t, y equal t of x, which is equal to angle 5x plus 1. Then for every xn here, yn for every xn will be t of xn, which is 5xn plus 1. And the probability of yn for every value of these equals the probability of the corresponding xn. واضحة؟ شباب, any question? No questions? Now, what happens if t is not monotonic? Not monotonic زي ما قلنا. Not monotonic means ايش؟ يطلع وينزل. Just sketch a better graph. Non-monotonic means it goes up and down. So for example, for every y, for every y in here, what is the how many values I have for x? I have this value x1, I have x2, I have x3, I have x4. خلينا نقول بعد كده يزيد بس عشان ما نعقد الموضوع. Oops. How to remove what I did. Yes. طيب. So assume So we assume that it goes like this up كده. طيب. So if this is x here, what are we plotting here is t of x. Okay. So now for every value of y, so here yn corresponds to four values of x, which is x1, x2, x3, and x4, right? And hence the probability of yn equals what? شباب?
Summation of the all probability for x1,
Exactly.
x2, x3, x4.
Excellent. It's basically the probability of x1 plus the probability of x2 plus the probability of x3 plus the probability of x4. Why? Because the event of xn, event that y equal yn, corresponds to the events, the mutually exclusive events that x equal x1, x equal x2, x equal x3, and x equal x4. And hence we write it here in terms of this equation. The probability of y equal y equals the probability of x such that it's the way we read it, such that tx equal y. So these are the zeros for this equation. واضحة يا شباب؟ Okay. Let's have an example. We have this now, y equal tx, which is given by this. T minus x squared plus x cubed over 3. First of all, is this monotonic or non-monotonic? برأيكم?
Non-monetary.
Why?
Because it is
XQ.
increasing at some point, and
Because we have x squared, right?
X square and x cube.
And x cubed. Okay. So now let's see. In the question, so this is the PDF of it. احنا ما كتبناها كفانكشن لكن it tells you that the probability that x equal minus 1 equal 0.1, x equal 0 is 0.3, x equal 1 is 1.4, x equal 2 is 0. We have this PDF of x. X can take how many values, ma'am?
4 values.
4 values only. So from minus 1 with a probability of 0.1 and 0 with a probability of 0.3 and 1 with a probability of 0.4 and 2 with a probability of 0.2. Now we are interested in finding the PDF of y. How to find the PDF of y? First of all, we need to find what are the values that y takes. So let's see. In order to find what the values that the y takes, simply we substitute for every value of x. So for when x equal minus 1, t of minus 1 gives you 2 over 3. Okay? When x equals 0, t of 0 gives you 2. When x equal 1, sorry, t of 1 get you 4 over 3. And when the last value, when x equal 2, gets you t of 2, which is 2 over 3. So how many values does y take here?
3 values.
3 values only. The first one is 2 over 3. The second one is 4 over 3. And the last one is 2, right?
Yes.
Okay. So in order to find, so basically we have 4 values for the y. So simply we need to find what is the probability of every value. So the probability that y equal 2 over 3 equals what? When does y equal 2 over 3? When x equal
Minus 1.
minus 1 plus when x equal
2.
2. Yeah, 2. 2 over 3 in y, we get it when x equal 2, when x equal minus 1. Okay, which is point, minus 1 has 0.1 and 2 has 0.2. So we have 0.3. Okay, so the probability that x equal 2 is 0.3. 2 over 3, so the probability that y equal 2 over 3 is 0.3. واضح يا شباب, how did we find this?
Yes.
Right, now the probability that y equal 4 over 3, the second value. When does y equal 4 over 3?
X equal 1.
When x equal 1, which is 0.4. The probability that x equal 1 is 0.4. Okay? And the last thing is y equal, the probability that y equal 2. So this is here 0.4. Y equal 2 corresponds to x equal come?
0.
0.
0. Y equal 2 corresponds to x equal 0. And the probability that x equals 0 is come? 0.3.
0.3.
Right?
3.
And because of that we have 0.3. So here we have 0.3. So it's very simple, as you can see. Simply you need to find the values that y takes given what are the values of x by applying the function t of x and then finding the probabilities of these y. Let's have another example. Y equal t, for instance, t1 of x, which is x squared. Okay, for the same example, for the same fx. Then what are the values of y in this case?
You
t
mean
of
probability
minus. Yeah, now أول شيء قبل ما نطلع probabilities we need to find what are the values of y, right?
Yes,
Yes.
we substitute for each value of x to find the value.
Yeah, so exactly. So t of minus 1, how many values x take in this example?
4 values.
4 values.
4 values again. So t of minus 1 is what? It's minus 1
1.
square, right? Which is 1.
1.
And t of كم كانت الثانية؟ 0.
0.
0 is 0, right? 0 square is 0. T of, what is the second, the next
1.
value?
1.
1, which is 1,
1.
right? And t of
2.
2,
4.
what do you get? 4,
4.
right? So how many values y take here?
Values.
Or 3 values, right? 3 values. So what is the probability that y equal, first of all, 1? We have the first value is 1, the second value is 0, so we have 1 here, we have 1 here, and then we have 0 and 4. What is the probability that y equal 1?
Probability x equal minus 1.
minus 1
Yes,
and
Plus
x equal 1.
exactly. Which is equal to come? Minus 1 is 0.1, and 1 is come?
0.4.
0.4. So we have 0.5, right? And we have another two values. The probability that y equal, so what to do here? Okay, let me just have some space. So the probability that y equal كم الفاليو الثاني حقت y? Y equal 0, right? What is
0
equal
and
this?
1 and 2.
Yeah, so probability that y equals 0 is what? The probability that x equal
0.3.
Equal to 0.
0, which is 0.3. The last probability of y equal كم?
2.
Y is not equal to 2. What is the value of y? The last value of y? شباب
4.
4. هذه هي. E of 2 is 4. Okay, so it's 4. And this is equal to the probability that x equal كم?
Equal to
Equal to
Equal to, which is point كم قلنا? 0.2.
2.
Exactly. So we have here the PDF of y looks like this. This is y, the PDF of y. We have how many values قلنا? We have 1, we have 0 first of all, and we have 1, and we have 4. What is the probability of y equal 0 قلنا?
0.3.
0.3, right? What is the probability that y equal 1? كم كانت?
0.5.
0.5.
5. And the last one, what is the probability that y equal 4?
0.2.
0.2. Okay, this is another example. طيب واضحة يا شباب, how do we find this? Any question? طيب, this section is optional. I will not go through it. So those of you who are interested, you can just look at it and read it from the textbook. So I will not go through it. Now the last practice problem is that I want to go through is this. Now we are not in the continuous range. We are not in the discrete. This is a continuous random variable. So we have x is uniform random variable over -1 to 2. And we have y equal x squared. Find and sketch the PDF of y. So x looks like this. The PDF of x looks like this. It's uniform between -1 and 2. If it is uniform between -1 and 2, what is the amplitude here?
1 over 3.
1 over 3, 1 over the difference. So that the area equal 1. So it's 1 over 3. Okay, and I have y equal x squared. So now how to find the PDF of y? I'm interested in the PDF of y. ايش رايكم? What do we do? Is this monotonic or non-monotonic? So if
Monotonic.
you look at it between -1 and 2, and this is x and this is y equal t of x, right? In order to know whether it is monotonic or not, we need to sketch y. Yx equal x squared. So if y at -1 is equal to كم? 1, right? And it goes like this. بس خلينا أكبر الرسمة شوي. This is y equal t of x. So y equal t of x. Okay, so at y is 1, at x equal -1, what is the value of y? Was 1, right? At 1, it is also 1. and it goes like this. It's x squared, right? But after 1, at 2, what is the value of y?
4.
4, right? So this is 4. So it goes like this. Okay. So is this monotonic or non-monotonic?
None.
Non-monotonic, right? Okay, excellent. So it's non-monotonic. However, between minus 1 and 1, it has 2 zeros. Right? صح? And between 1 and 2, it has how many? How many zeros we have? شباب
1 0.
This
1
one.
0. So we cannot blindly apply f of y equals the summation I equal 1 to 2 f x of x1 xi, sorry, divided by dy dx at x equal xi. We cannot just blindly do this because in certain range of x we have 2 zeros, so we have 2 values here, and in certain range of x we have 1 value. So we cannot just blindly have a summation of 2 all the way. So we need to divide the range into 2 ranges. From minus 1 for x belongs to minus 1 to 1, because we have here 2 zeros, and for x belongs to the rest, 1 to 2. واضح شباب؟ So this does not apply to all x. شباب واضح اللي سويناه؟
واو دكتور.
طيب, so basically between minus 1 and 1, how many zeros we have here?
2.
2 zeros, right? So fy of y equals 2 zeros, which is fx of x1 divided by dy dx is come. What is dy dx?
2x.
2x.
dy dx is 2x. And this is 2x1, huh? Plus fx of x2 and divided by 2. What is the value of dy dx again? It's 2x over, you have 2x2, right? Which is equal to, the PDF of x is come 1 over, what is PDF of x? What is this? What is this equal to? What is the PDF of x equal to?
1 over 3.
1 over 3. Okay? And here we have 2x1 or 2x2. What is x? What is the value of x? X here equals plus minus square root of y, right? Okay? So here we have 1 over 3 of square root of y. Sorry, where is this? Square root of y. Okay, and we have 2 values of these. So we have multiplied by 2.
What about the 2 in the...
Sorry, there is 2,
Zero.
yeah, sorry. I forgot to. So here we have the denominators, we have 2 square root of y, and we have 2 of these. So the 2 cancels the 2, and we end up with 1 over 3 square root of y. Okay? Now for the second range, which is we have 1 0 only, اللي هو between 1 and 2, fy of y will have the same shape. However, it will be fx of x divided by 2x, what evaluated at x equal square root of y. We have only 1 0 here, which will be 1 over 3, right? Divided by 2 square root of y. So it will be 1 over 6 square root of y. واضحة شباب؟
Doctor, in this
تفضل.
example, we cannot say it is non-monotonic because it is 0 from minus infinity to minus 1, and then say it is increased from minus 1 from 0 to 1 to 1 over 3 at minus 1, and then decrease
لا
at
لا يا شباب يا شباب, when we say monotonic or non-monotonic, we mean y equal tx, the function. The PDF ما لها علاقة تكون monotonic ولا لا. The function, we are talking about the function. شباب, all our discussion about monotonic or non-monotonic, we talk about the function. Y equal t of x. Does it increase all the time or decrease all the time? We call it monotonic. Or if it goes up and down, we call it non-monotonic. We talk about the function, not the PDF of x. واضحة؟
okay, it's okay now.
تمام. So now here we have for two ranges from x equal minus. So basically this is the PDF. The PDF of y equals two ranges. We have 1 over 3 square root of y for y between come. X between minus 1 and 1. So y between come and come. What is the corresponding value for this range? For x equal between minus 1 and 1. Y is between what and what? What and what?
-1 and 1.
Yeah. Y is between. No, not minus 1 and 1. Y cannot be minus 1. Y is x squared. Okay. It goes between 0 and 1. And it's 1 over 6 square root of y when y is between 1 and 2. Yes. And when you sketch this, we'll get this. So this is basically 1 over 3 square root of y.
Is it 2 or 4, Doctor?
نعم.
Is it 2 or 4, the value of y?
Sorry, 4. Thank you. Yes. Y goes to 4. Because x goes to 2, y goes to 4. Thank you. So if you plot this, it will look 1 over 3 over square root of 1 over 3 square root of y from 0 to 1. So at 1, this is equal to 1 over 3. Now, from 1 to 4, it will look the same function, but it will be 1 over 6 square root of y. And at 1 here, it will be open طبعا. At 1, it will become 1 over 6. So there will be a discontinuity. واضحة الفكرة؟ كلير يا شباب؟ شباب, any question? How did you do this? So basically, when we talk about monotonic or non-monotonic, you need to watch for the different ranges of x. Because in some ranges, you might end up with 2 zeros. Some others, you might end up with 1 0, like in this particular example. And the solution needs to watch for these two ranges. Because you cannot just sum blindly for two values, for 2 zeros here, all the range. Because in this range, there was only 1 0 in this range, from 1 to 2. طيب, any question? أي سؤال يا شباب؟ طيب just reply to me in the private chat. No question ولا أي شيء. Clear أي شيء. Reply to me in the private chat. No question ولا clear أي شيء. Just for my record. Reply to the private chat يا شباب. طيب I already uploaded the chapter 3 under the content library since yesterday, so you can find it under the content library. So you have the annotated version. You can, if you would like to go through it, or you would like to go through the clean version, it's up to you. Okay. أي سؤال? Chapter 3 in general, any question? طيب, just very quick introduction about chapter 4 and we'll stop in 3 minutes. Chapter 4 is about multiple random variables. When do we encounter multiple random variables? So we'll talk about in this chapter the definition of the vector of random variables or multiple random variables. Since we have multiple random variables, then we will talk about what we call joint distribution, because we have more than one random variable. We call it joint distribution function. Joint density function, because we have also more than one random variable. We'll talk about conditional distribution and density function. When we condition on one random variable, what is the conditional distribution of the second random variable? And we'll define what we mean by statistical independence, which is very important and powerful phenomena. We need to understand it. And then we'll talk about the distribution and density function when we have a sum of random values. And then we'll end up with what we call central limit theorem. Okay, so most of these, they will not make sense to you now. However, as we go, inshallah, it will be clear. So when we talk about vector of random variables, we are talking about two random variables at one time. So for example, if I'm interested in describing the position as a point in a plane. So if I'm interested in the position, not in the angle. لو تتذكروا كنا نتكلم على ال rotation and we always define the angle, right? Now, if I'm not interested in the angle, if also I'm interested in the position. So basically, I'm interested in this position. In this position, I can describe it in terms of two random variables, x1, so the x and y, right? Or I can define it as two random variables, which is the theta and the radius. So for example, if you are hitting a target, then basically you are interested in where the point lies, where your bullet comes and stops. Then in x1, x2, the coordinate, so the x and y. You might be interested in the x and y. Now, x is a random variable and y is another random variable. Okay? Now, what we will do in chapter 4 is try to study how can we describe these two random variables together. We will define them, we'll talk about their distribution and so on. That's enough for today. This is just to give you an introduction. Next time, inshallah, we'll continue. Time is up. Those of you who would like to leave, you can leave. Those who have questions, you can ask.
Doctor, what is the material for the midterm?
The midterm up to chapter 3.
Okay, thank you.
Okay, so this doesn't mean that you don't pay attention for the next 3 weeks, because it will be in the final and the quizzes.
No, I didn't say that.
Yeah, I know. I'm just kidding with you. لا لأن في شباب خلاص مركزين على الميدتيرم ينسوا كل شيء. Please يا شباب يعني continue to focus on the rest of the material. However, we have enough time to study for the midterm. لأنه غطينا material already. انتهينا.
دكتور
تفضل.
ممكن تنزل الافريج للكويزات اللي راحت؟
So you have the average for the quiz 1 and quiz 2. You can just average them. We had only 2 quizzes.
On the blackboard or? No, average of the class, I mean.
I sent after every quiz, I sent the average of the quiz.
Okay, thank you.
And you can just calculate. أسئلة ثانية يا شباب. Okay, so we'll see إن شاء الله on Tuesday بإذن الله. نراكم. السلام عليكم.